Very good morning. In the last classes, we have discussed about the classification of elements and the periodic table. On the basis of that, we have discussed some earlier periodic tables proposed by de Bournier and Newland's uh, law of octaves. And the next one is Mendeleev's periodic table. And whose table is best among all these three tables, Nana? Older tables, Mendeleev's periodic table. Which has given the idea on groups. Yes, horizontal rows periods, vertical columns groups. He has given a best information than all the previous tables. Previous periodic laws. He has given best idea to the modern periodic table. And on the basis of the periodic law, what is the information given by periodic law? All the properties of elements are on the basis of atomic weight. And coming to the modern periodic table, there we have a clear idea on the periodic law, modern periodic law, which states that the properties of the elements and the periodic functions on the basis of atomic numbers rather than atomic weights. So ascending order we are following. And while coming to the positions of the elements in the modern periodic table, on the basis of quantum numbers, electronic configuration, valency electrons, which is the idea given by Mendeleev. Valency, on the basis of valency of atom. Valency electrons on the basis of valency, and the outermost shell electrons only has given the information, and he predicted before only the newly invented elements, and that information also he given very well. And on the honor of him, 101th element is named as Mendelevium. So next one is modern periodic table. Here we have discussed about the K element subshells, and here we got an idea on atomic structure usage. Why we have to understand the structure of atom? So to understand the elements and periodic table, the classification, first we have to understand the structure of atom. Why? Because all the electronic configurations, whatever we wrote, or we are writing from the understanding of structure of atom only. So due to that, structure of atom is very much needed. So in that manner, we can understand the necessity of that. And the next one is about main shells and subshells. So here the groups are the vertical columns in the periodic table. There are 18 groups in long form in the periodic table. In this manner, those were arranged. See, 1A, 2A, 3A, 4A, 5A, 6A, and 7A, 8A. So 3B, 4B, these all are. And here, three columns are comes under 8B. And the next, lanthanides, actinides are separately. How those are and why those are separately arranged in the periodic table, that we have to understand in today's class. Here, while coming to the groups, we have discussed how those are divided into columns according to the properties, and how those are divided into S block, P block, D block, F block elements. Can you say, anyone can say? The last entering element, the last entering electron into which subshell? The last electron entering into which subshell? On the basis of that, for example, if we write electronic configuration, the last electron entering into S subshell, those all our elements are comes under S block elements. If the last electron entering into P subshell, those all are comes under P block elements. If last electron enters into D subshell, those all are comes under D block elements. If last electron entering into F subshell, those all are comes under F block elements. In that manner, we can understand the groups. And the next one is about periods. How the periods are divided. These are all based on the main shells, not subshells. Groups are based on the subshells, and periods are classified based on the main shells. If the electron enters into the main shell, exists only in the main shell, first main shell K. So those all are comes under first period. Similarly, second, if the electron enters, last electron enters to KL. The electrons are existing in two main shells, K and L. Those all are comes under second period. So in that manner we can understand, and on the basis of that only about alkali metal family, chalcogen family, halogen family, noble gases, these all we have discussed. And alkali metals which are coming from the plant ashes obtained from plants. So due to that those are named as group 1A elements are called as alkali metals family. Here group 1A, these all are alkali metals, and the group 2A are alkali earth metals, and the family which is related to the chalcogen family. So ores which we are getting from ores are called chalcogen family, and halogen family, sea salt which are getting from sea salt like fluorine and all, those all are comes under halogen family 7th A group. And noble gases which are having stable configuration, zero reactivity, zero valency, that's why these are also called as noble gases. Zero group elements, also we are calling these as zero group elements. And up to here we have discussed. Yes, up to here only na in the last class. And the next one, these we have to understand now. And the number of elements in periods depend on how electrons are filled into various shells. How electrons are filled into various shells. Each period starts with a new main shell that I told you now only. K shell, KL, KLM, and in that manner we have discussed in the previous only. Now we'll see. Here the next point is S subshell, the main shell K. The main shell K contains only S subshell. Yes, and K L shell up to SP. So in that manner we can understand that here. Once see, these are the main shells. K is K, N is equals to 1, N is equals to 2, L, M, N. In that manner, shells, main shells are divided. K, L, M, N, N is equals to 3, N is equals to 4. In that manner, main shells are there. For the first main shell K contains only one subshell, that is 1s. Here only one subshell, 1s, and coming to the N is equals to 2 L shell. Here we have 2s and 2p we have. And while coming to the M, N is equals to 3. Here 3s, 3p, 3d we have. And while coming to the N is equals to 4. N main shell here 4s, 4p, 4d, 4f we have. So in that manner subshells we have. So according to that periods are divided, and the elements are grouped into different. For example, first period, except that when main shell is filled with respect to the S and P subshells, the first period starts with K shell. The first main shell K contains only one subshell 1s. And for this subshell, only two types of electronic configurations are possible. Those are 1s1 and 1s2. Hydrogen and helium only comes into first period. See, H here we have, and helium we have. Only two elements are comes under this. And the second period starts with the second main shell. L shell has two subshells, namely 2s and 2p. 8 types of configurations are possible. 8 types. Why 8 types of configurations are possible for this? So 2s1, 2s2, and 2p1 to 2p6. Yes, 8 types. Why? Because here 1, 2, 2s1, 2s2, up to here we have. And 2p1 to 2p6, how many, Nana? 5. 2p1, 2p2, 2p3, 2p4, 2p5, and 2p6. Total these are 6 types, and these are 2. Total 8 types for L main shell. These are second period elements. Okay na? And while coming to the third, N is equals to 3. How many types? 3s1, 3s2, and 3p1 to 3p6. These are 6, Nana. These are 2. These are 6. And 3d 1 to 3d 10. So these are 10. Total 18. Yes, 18 types of electronic configuration for third period. And the next one is fourth main shell. This shell N has 4 subshells, namely 4s, 4p, 4d, 4f. But while electrons are being filled into the shell, the electrons enter the atom in orders 4s, 3d, and 4p. Due to this, the fourth period contains 18 elements. So in that manner, fourth period contains 18 elements, and here 4s is filled. So there are third period contains only 8 elements. Third period contains, first period contains how many elements? 2, Nana. Second period, first one and second one contains how many? 8 elements. 8 types of electronic configuration and 8 elements, and third one contain 18, Nana. Sorry, 8 only. Third period contains 8 elements and fourth one contains 18 elements. In that manner, fifth period 14 elements. Same line we can explain. There are 18 elements in the fourth period and 18 elements in the fifth period. At the same time, 18 in the fifth period and 32 elements in the sixth period, and the last seventh one contain 14 elements. Seventh period contains 14 elements from the F block and 10 elements from the D block, 6 elements from the P block. So totally how many are there in the sixth period? 14 plus 10, 24 plus 6. How many? 30. And 4F elements are called lanthanides or lanthanides. Elements from these we can understand. See here. Seventh period I will explain. Just a minute. Here see. Here we have cesium 55, barium 56, lanthanum 57 and hafnium 72. So what is the difference here, Nana? Yes, some elements missed. Yes, 57, then continuation is 72. So why we kept these lanthanides? Lanthanum to we have up to electronic configuration 58 to 57 we have here. 58 to 71 we have separately placed. If we place here only, how the periodic table looking like? Is there possibility to maintain these all here? So for that, these are grouped as separately, placed in another way, in this manner. If we place this here, we'll get a disturbance in the atomic numbers ascending order. So that's why we kept these all are separately. And here in the seventh period also like that, Nana. 89 after 104. In between some elements are there, those are actinides. Actinum to the remaining up to this. What is this? LR. Yes, Lavernama, Lavernacum. So these all are comes under here in between. So these are separately placed in this manner. So in this manner we can understand the lanthanides and actinides are placed separately. Why? Because of the adjustment of the order of atomic numbers. Those are placed separately. So 32 elements in the sixth period from cesium to Rn 56, and which includes 2 elements from the S block also. Totally we'll get 32. And 4F elements also called as lanthanides or lanthanides. Elements from here CE 58 to Lu 71. These all are having same properties. That's why according to their properties they are placed and they are placed separately in that manner. Lanthanides are having same properties. And the seventh period is incomplete and contains 2 elements from S block. Yes, 14 from F block, 10 from D block. And from P block, how many, Nana? Some from P block, not completely filled. And the actinides are separately placed from the seventh period. And F block elements are called as lanthanides. 4F block here. And these are F block elements. Our lanthanides and actinides are from 4F block only, and separately at the bottom of the periodic table for adjusting the atomic number arrangement. And why it is not completely filled means newly invented. Maybe newly invented will be there. So for those giving space, those are unfilled, not completely filled seventh period. So in that manner we can understand the periodic table. I think you got clear idea on the periods groups. How the groups are separated? On the basis of subshells. And the electrons enters into subshells. How? And on the basis of the main shells, periods are divided into 7 periods. Is it okay for you now? In this manner we can understand. Okay, next one is metals and non-metals. In the 8th class also you have studied about metals and non-metals. Are you listening, children? In the 8th class also you have studied about metals and non-metals. You have learnt about the properties of metals in the chapter metals and non-metals. 8th class you have studied. There we have studied about the physical properties and chemical properties also. And the elements with 3 or less electrons in outer shell are considered to be metals here. According to that our concept, previously we studied about physical properties, how they are looking, appearance, how lustrous, sonorous, all we have discussed physical properties. And reacting with oxygen, reacting with hydrogen, yes, which are acids, which are bases. On the basis of that, in that manner we have discussed. And here on the basis of electronic configuration, on the basis of valency, so the elements which are having outermost only 3, so those with 5 or more electrons in the outer shell are considered as non-metals. And less electrons in the outer shell, 3 kanna takku unnavi metals, and 5 or more than are comes under non-metals. So in that manner we can understand. We may find some expectations to these D block elements are metals, and they are known as transition metals. D block elements, 3rd group to 12th group, those all are comes under D block elements, because in the electronic configuration the outermost electron enters into D subshell, and the metallic characteristics of D block elements decreases gradually from left to right. So D block elements lo metallic characteristics left to right decrease avutayi nana. Starting more metallic qualities are there, while going through right side those are decreasing. Lanthanides and actinides are actually 3rd group, and which is within the transition elements. Those all are comes under transition metals, transition elements, hence they are called inner transition elements. Why? Because inner, in the 3rd group we have, see, in the 3rd group only we have lanthanides and actinides. These are transition, and again inner transition. Again subcategory we are taking in that 3rd group. So these are comes under 3rd group only. These two, lanthanides and actinides, which are comes under inner transition elements. And some are metallites or semi-metals, intermediate between the properties of metals and non-metals. Some are having some qualities of metals and some qualities of non-metals. So due to that, metallites, those we are calling as semi-metals or metallites, they possesses properties like metals but brittle like non-metals. They are generally these: silicon, germanium, boron. These all are comes under metallites. Where are those, Nana? Silicon and all. Some are semi-metals or metallites we are calling. So in this manner we can understand. Where is B? Boron? Yes, C. B and Si, silicon. Where is silicon? Yes, silicon we have. So in that manner we can understand these all are comes under according to their properties. Metals ki, non-metals ki middle low intermediate properties they have, means those all are comes under semi-metals or metallites. All elements in S block are metals, whereas in P block 18th group there are metals, non-metals and metallites. 18th group metals are there, metallites are there, non-metals also there in that group. In periodic table you will notice a staircase like demarcation, and the elements to be to the left of this demarcation are metals, right of this demarcation are non-metals. The elements on that staircase are metallites. Staircase they have given a, yes, below that are here they have given some staircase. See, these all are comes under these bismuth, silicon, these ferrum, these all up to here only. These all are comes under metalloids, and below that, above that, some these are metals and these are non-metals. So in that manner we can understand. Here they have given a staircase, steps like arrangement. So arrangement lo marking undi kada, demarcation. Staircase like demarcation is there. So the elements which are left to that, left means below that, those are metals, and right to that means above that, those are non-metals. Here left means this side. Left of these are metals, left of these staircase metals, and right of these are non-metals. These all are non-metals. In that manner we can understand the metals and non-metals concept. And the periodic properties of the elements in modern periodic table. So what are the properties processed by modern periodic table? Basis of electronic configuration and atomic numbers, atoms of elements, number of elements in the atoms, number of electrons in the atoms. On the basis of that only we are arranging. And physical and chemical properties are related to their electronic configurations only. So here the dilemma with what removed, Nana? Dilemma with anomalous series. Yes, anomalous series dilemma removed by modern periodic table. Series contained elements atomic weight actually in increasing order, ascending order undali, but here the dilemma will comes. So this concept of inversion removed, this dilemma removed by modern periodic table. So electronic configuration and number of electrons we are considering. Outermost shell, valency electrons. Yes, what is the valency? That concept we are going to see now. Valency shell means what? Valency, the combining power of an element with respect to the hydrogen and oxygen. What Mendeleev told, Nana? On the basis of reaction with oxygen only divided into groups. Here also we have to consider that valency. Modern periodic table also considered on the basis of valency only. The combining capacity of an element with respect to hydrogen, oxygen, or indirectly any other element through hydrogen and oxygen. Valency or valence of an element was defined as combining power of an element with respect to hydrogen, oxygen, or indirectly any other element through hydrogen and oxygen. The combining capacity of element through hydrogen and oxygen. And valence of an element with respect to hydrogen is the number of hydrogen atoms with which one atom of the element chemically combines. How many it can able to combine, how many with how many number of hydrogens it can able to combine. So on the basis of that, valence of element depends with respect to the oxygen, twice the number of oxygen atoms. Why? Because the valency of oxygen is how much, Nana? 2. Valency 2. So that's why the numbers we have to take twice at a time. At a time twice we have to take. So any element with atomic valency 1 ఉన్న తీసుకుంటే 2 we have to combine with one oxygen element. So in that oxygen atom, in that manner we can understand the valency concept. The combining capacity of an element is called valency of that electron. The outermost shell, loosely removable, easily removable electrons are there, those that is comes under valency. And here notations from 1 to 8 groups, but it is 18 group number as per IUPAC numbering. 18 groups. 1 to 8 we are calling. Again subgroups we have A, B, and 3 are separately we are taking. Those are 8A, 8B are 8B containing 3 columns. In that manner totally we got 18 groups numbering. And sodium chemically combines with one atom of hydrogen to give NaH. Therefore valency of sodium is 1. And one atom of calcium combines with one Ca is 2. Why? Because valency of calcium is 2. It wants to give 2 electrons to get the helium to get the electronic configuration of noble gas. Noble gas configurations రావడానికి ట్రై చేస్తేనన్నా always elements wants to get the stable configuration. By removing it will reach us to the noble gas configuration. By gaining oxygen, by giving calcium reaches the noble gas configuration, and by gaining oxygen reaches the noble gas. These both will become as stable. So valency of oxygen and valency of calcium is 2. So in that manner we can understand valency of the element with respect to the hydrogen is its traditional group number. So group V or above, its valency is 8 group number. So according to that we can understand chlorine valency is 8 minus 7 is equals to 1. Chlorine valency is 1. 17 is the atomic number. So on the basis of atomic number, it is easy to understand the valency of that by comparing noble gas configurations.